Okay, students, this is a lesson on factoring the difference of two squares. So, when multiplying binomial conjugates, binomials of the form a plus b and a minus b, we obtain a binomial of the form a squared minus b squared, which is called a difference of squares. And so, what they're saying is that if we multiply a plus b times a minus b, we would get a squared minus b squared. So how is that? Well, this is a binomial times a binomial. And also, when it says conjugate, it's saying that one of these signs is a plus and one of the signs is a minus. But everything else, the a and the b are the same, but the signs are different. When that happens, the following will happen every time. So when you FOIL this, you get a squared, a times negative b is negative ab, b times a is positive ab, then you have b times negative b, which is negative b squared. But notice that the negative ab and the positive ab will cancel out, leaving you with the a squared minus b squared. So as long as those signs are different here, then the middles will cancel out and you will get something of this form right here. So let's go over another one. So for example, if I gave you the problem, so here's another example. If I gave you the problem, what is 2x plus 3 times 2x minus 3? Then you will FOIL this. That'll be 4x squared minus 6x plus 6x minus 9. Again, as you can see, the middles will cancel out. And then you'll only have 4x squared minus 9. So notice that what ends up happening every time is that because of that, those signs being different, that the middles will cancel out because of that negative and that positive. All right, so that brings us to what is called a difference of squares. So what we just did was multiply binomials together. But what if we were asked to factor something that looks like this or something that looks like this? Then we would get these as our answers, as our results. So I didn't mention that this is the second section of chapter 5. So this is 5.2. But let's go over the list of perfect squares. So let's go over here to the right, the list of perfect squares. So let's write down the list. So 1 is our first perfect square. So 1, because 1 times 1 is 1, or 1 squared is 1. So 1 squared equals 1. 2 squared equals 4. So 4 is a perfect square. What is the next perfect square? 9. 16. 25. 36. 49. 64. 81. So let's not get it mixed up. The perfect squares are these numbers here. If you notice these numbers, then there's probably a difference of squares problem that you're dealing with. There's probably a difference of squares problem. So it's best to be familiar with these highlighted numbers here. And of course, the perfect squares continue on, but these are the numbers you're probably going to see the most. So factoring the difference of two squares. First, you need to be able to recognize what a difference of two squares is so that you'll know that you should be factoring it. And so here's how you're going to know. Of course, it's going to look like this in this little format. And these are the factors over here. The factors for a squared minus b squared is a plus b times a minus b. Again, we just proved that earlier by multiplying a plus b times a minus b. Because that's what a factor is. When you multiply one factor times the other to get that product of a squared minus b squared. So you need to know how a difference of squares look. First, so let's go through the criteria. Is the expression a binomial? Now, if you look at a squared minus b squared, that is a binomial. You have two terms represented. Second, is there a minus sign? Hence, why they call it a difference, right? Because of the minus in the problem. And third, are the terms perfect squares? And again, we just went over what are perfect squares. Well, it's really when you square something, you get something else. So even if I put up here, what is a squared, and you get a squared is also a perfect square, even though we're dealing with variables. All right. So before we move on, just to a quick note is that a sum of two squares is not factorable. And what does sum imply? It means addition. So difference of squares is factorable, but something like this, a squared plus b squared, is not factorable. Let's go up here because I don't want to overlook this part here. So this is an example of difference of squares, and that's why I did the problem above up here. This example here, I showed you that these factors do indeed multiply to give you 4x squared minus 9. But this is indicating why this is a difference of squares here. There are two terms. It's a binomial. Coefficients are perfect squares. And what do I mean by coefficients? Is 4 on our list of perfect squares? Yes. Is 9 on our list of perfect squares? Yes. Is there a minus sign? Yes. Check. So all these things we're checking off. Is the degree even or zero? And the degree is 2 here. As you can see, that's the degree. So that checks off. Therefore, this is a difference. 4x squared minus 9 is an example of a difference of squares polynomial. And because of that, we can factor it to 2x plus 3 times 2x minus 3. So here I have a little chart where I first want you to identify the binomial as a sum of squares, a difference of squares, or neither. Then factor. So first, let's look at x squared minus 25. That is a difference of squares because you have x squared. You can find the square root of that, which is x. The square root of 25 is 5. 5 times 5, or 5 squared, is 25. You have a minus sign in the middle. You have a binomial. So it checks off all the boxes. You have an even degree of 2. So the factors are, and it will always be this. What is the square root of x squared? X. So x will go here and x will go here. What is the square root of 25? What's the square root of 25? It would be 5. And your signs will always be different, right? Plus, minus. Or you could have put x minus 5, x plus 5. I always write my plus first. It's just the way I do it. All right. And you can always check by doing what? If you said multiply this or FOIL it, you are on it. Okay, next. X squared plus 16. Identify the type as a sum of squares, difference of squares, or neither. This is actually a sum of squares. And what does sum imply? Addition. It's a sum of squares because of this plus sign here. And what did we say about the sum of squares? So let me go back to it, just in case you already forgot that we said that a sum of squares is not factorable. A sum of squares is not factorable. Now, I notice sometimes in WebAssign, they'll say put NF. What do you think that stands for? Not non-factorable, not factorable. And sometimes I see in WebAssign that the instructions say to type the word prime. Okay? Because there are no factors of x squared plus 16 other than x squared plus 16 and 1. Okay, so that means it's a prime polynomial. You can't factor it. All right, next we have a squared minus 1. And again, you can pause the video, attempt these yourself, attempt filling out this table on your own, and then you can watch me explain. All right, a squared minus 1 is a difference of squares because you have a times a will give you a squared. 1 times 1 will give you 1. You have a minus sign. So a plus 1 times a minus 1, if you multiply that, will give you a squared minus 1. All right, next we have w squared plus 54. What do you think that is? Classified as either sum of squares, difference of squares, or neither. Actually, it's neither because 54 is not even a perfect square. So we can't identify it as a... So we cannot identify 54 as a perfect square. So we can't say that this is a sum of squares if 54 is not a perfect square. We say difference of squares referring to perfect squares. And if it's not a perfect square, then it doesn't meet the criteria of being sum of squares. So neither, and we could say not factorable again, right? Or prime. So pay attention to what the instructions say in WebAssign for these. Next, 9 minus 4x squared. What do you think? It's a difference of squares because 9 is on our list. 3 times 3, 4x squared, 2x times 2x. So it's backwards, so we're just going to write it backwards. 3 plus 2x times 3 minus 2x. I want to point out that 2x minus 3 or 2x plus 3 times 2x minus 3 is not the same thing. Your signs will not end up being the exact same thing as 9 minus 4x squared. So be very, very careful about attempting to switch things around and you're not totally switching the signs properly. All right, 64y squared plus 1 is a sum of squares, which is not factorable or prime again, okay? Z squared minus 4 is a difference of squares, and the factors are z plus 2 times z minus 2. And again, you can always FOIL it out. X squared minus 10, another trick one. 10 is not a perfect square, so I can't call this a difference of squares. So neither non-factorable or prime. Next, y squared minus 4/9, another tricky one, but it is a difference of squares if you understand fraction rules. So you have y plus 2/3 times y minus 2/3, because if you multiply 2/3 times 2/3, you will get 4/9. So it works out. when you multiply those binomials together. 4x squared minus 1 is 2x plus 1 times 2x minus 1. What about 25a squared minus 9b squared? Well, square root of 25a squared is 5a, for example. The square root of 9b squared is 3b. And the signs, of course, will always be opposite signs. 36 minus x squared. That's written backwards. That's okay. You can write it as 6 plus x times 6 minus x, and it will work out. Next, we have mixed problems. X squared y plus 2x squared minus y minus 2. There is no GCF for these terms, but notice that we have 1, 2, 3, 4. 4 terms. 4 terms should trigger a method in your mind. And that method is factoring by grouping. So what does the first group have in common? Well, we have an x squared. Take that out. And then we have y plus 2. Y plus 2 to show back up. So we'll have to take out a negative 1 to make that happen. So we have y plus 2 here. Y plus 2 times x squared minus 1. But here's what I want you to notice. That x squared minus 1 is a difference of squares. It is factorable. And we need to always factor completely. Meaning you can't leave something still factorable. You have to factor everything. So this part right here, still factorable. So we have to break that down as well. So we have y plus 2, and we're going to break down x squared minus 1 into x plus 1 times x minus 1. And when you look back at all of these parentheses, nothing else is factorable. That's how you know you should move on. Number 2, we have 4 terms again. No GCF for all 4 terms. So let's group. We're going to take out a 4 here and get x minus y. And we want x minus y again. So it looks like we're going to have to take out a negative x squared, it seems. And then we have x minus y. And then always check this and make sure you get back everything before you move on to the next step. So we have x minus y times 4 minus x squared. And look what popped up again, a difference of squares. So we have x minus y times 2, right? Because 2 times 2 will give you the 4 plus x and minus x. Next, we have y to the 4th minus 16. That's a binomial. Your degree is even, and you have perfect squares. So we're going to split it up as y squared plus 4 times y squared minus 4. I'm hoping you realize that y squared minus 4 is a difference of squares. And I hope you also realize that y squared plus 4 is a sum of squares which cannot be broken down. But we can break down what's in pink here. Y squared minus 4 is the same thing as y plus 2 times y minus 2. That's why we make that substitution. Moving on to number 4, we have 4x cubed minus 49x. First, there's actually a GCF of x. So we take that out. We have 4x squared minus 49. But lo and behold, this is a difference of squares. So you keep the x. Please do not get rid of it because it is still a factor, an integral factor, in order to multiply everything to get that 4x cubed. So when we break down what's in pink here, we get x times 2x plus 7 times 2x minus 7. Moving on to number 5, we have 162x to the 4th minus 2. We have a common factor of 2. We take the 2 out and we get 81x to the 4th minus 1. This is definitely a difference of squares, so we must break it down as well to 9x squared plus 1, 9x squared minus 1. However, 9x squared minus 1 is also a difference of squares. So really we have 2 times 9x squared plus 1 times 3x plus 1 times 3x minus 1. Moving on to number 7. Notice that it starts with a negative leading coefficient. You could factor out that negative and it will switch your signs to 49x squared minus 16. Keep that negative in the front and break down that difference of squares to 7x plus 4 times 7x minus 4. And you could have written this as 16 minus 49x squared, right? If you wanted to change it, then it would have been 4 plus 7x times 4 minus 7x. I would take both answers. And then lastly, we have 9xy squared minus 4x. First, always look for the GCF. And I do see a common factor of x in both, so we take that out. We have 9y squared minus 4. That's a difference of squares, so we break it down as x times 3y plus 2 times 3y minus 2.